for later on in this presentation. That's for during the face-off. So first of all, logic bomb and time bomb. I'm pretty sure that everybody is familiar with that. So it's a piece of malicious code that is dormant in your code until something triggers it. If that triggering mechanism is related to time, then we call it a time bomb. There are like numerous public disclosures over here, and it's mainly about comparing hard-coded date and time against the current time. What we've seen so far is that if you're really destructive, if you have a destructive piece of code, you're using a time bomb to set it off. You choose like a date, like your birthday, or when you're a year laid off, or something like that. One interesting case over here is the logic bomb. Hacker gets 8 years for failed stock rigging. So UBS employee planted the logic bomb into the code and went short on the stock. So the logic bomb went off. It deleted like files over 1,000 of computers. He got caught. He was prosecuted. It was 8 years in jail. And unfortunately for him, the stock didn't even go down. So he was like completely screwed. What we actually figured out, or what we found in code, was not that it was really destructive. So what we found in code was that people used it for various reasons. For instance, in the first case, what we figured out with this logic bomb was that they tried to bypass control mechanism. I'm not going into detail of what they exactly did, but so there were like checks installed, and after a particular date, these checks were no longer valid. So you could easily bypass these checks. Another one that we found is instead of being truly malicious, what you can do is update queries at random, change some data, and this is really hard to track it down. If you do not find this particular piece of code, you're going to look into where you're updating your queries or whatever is related to the fact that your database is changing, and you will not look at this piece of code. So this is really hard to spot or to track down if you do not find this inside the thread. Backdoors and secret credentials. This category is all about securing your future access to the machine. And you can achieve that in like numerous ways. What you can do is adding additional credentials, adding a master password, some code that allows some remote access to the machine. You're bypassing some authentication mechanism, or even just a way to execute commands on the machine is enough to grant yourself access later on. A couple of examples over here. Well, I've explained already the Borland interbase example where you insert like a hard-coded username and password. Another one to secure your way afterwards was the WordPress backdoor. So you can still execute commands on the server itself if you know the special parameter. So knowing the special parameter means you can execute whatever you want on the server. So later on you can grant yourself access, you can execute whatever you want on the server. The last one that we found in code was inserting some special credentials at startup. So if you're starting up your application, the first thing that's executed, well, after a while, the credentials database is created, and they inserted a line of code that added an additional pair of credentials to that credentials database. So later on, you could come back and use the username insider and the password thread to grant yourself access to that particular machine. And so backdoors and secret credentials are not like limited to these quote normal applications. All applications can be backdoored. For instance, Optics Pro, it's actually a backdoor program containing a backdoor because it was like a master password to grant yourself access. Sub7 is a Trojan with the backdoor, so it's not limited to normal applications. Nefarious communications. So nefarious communication is about a fixed communication channel to transfer data outside of the organization. So we cannot execute whatever we want on the server, but it contains some code in it, and we can poke it and trigger it, or it connects back to us and it gives us some data. So it's an excellent way to transfer sensitive data out of the organization. So a couple of examples over here. So you can do that, for instance, by the server opening a socket or opening a network connection to our machine and transferring data to us, or you can actually, the server containing some mailing application that mails once in a while some secret information to us. And the way you can, the way that code becomes active is sometimes it's time-based, so on a certain date or on a regular basis it sends over some information, or you can actually monitor the database, some confidential database, and if that database is updated, it's going to transfer the whole database to our server. Or you can actually poke it. If you know how to poke it, it gives you back the information. A couple of examples over here. So this is about making a making a socket. Creating a new socket, and they were actually monitoring one specific file. I've changed it to confidential file, so they were monitoring one specific file, and if that file changed, it created a new socket on port 666, and it transferred the whole file out of the organization. This is a very similar one. It's pretty much the same, but instead of opening a socket, over here it's posted to a website, so to an evil website. Again, you can monitor the file and transfer it out, or you can like manually poke it. The email, so the BlackBerry email spying case. So in a particular country, this update was advertised as a performance update. When you actually decompiled the performance update, you found the following piece of code. So it contains like some forwarding mechanism that for each mail you receive on your BlackBerry, it was also forwarded to that particular address. That was actually deliberately into the code, and it was there to comply with regulations. So, work of Jeff Williams, dynamic code injection and manipulation. This category is all about changing, adding, compiling code on the fly. So you have some source code in your application and you compile it on the fly and execute it. We got inspired by Jeff Williams' work on this particular category. So he enumerates like a lot of categories, like abuse of reflection, where you rewrite read-only variables, resource rewriting, compilation on the fly, abusing class loaders, pretty neat stuff. One example over here comes out of his work, out of Jeff Williams' work. It's the abuse of reflection. So what you're actually doing over here, so you have some final strings in your application. You're not able to modify it. You're not able to change the data of these final strings. What you're doing is you change the string class. So you change the string class in such a way that all final strings become writable. So it doesn't matter anymore if there's final with the string. You can actually rewrite all the final strings. Obfuscation and camouflage. Over here, you're trying to hide from different actors. For instance, you can try to hide from auditors. These days, we see that people try to hide from tools too. But at the beginning, it was mainly about hiding from people looking at the code, doing manual analysis on the code. And the way they do it is they make like really subtle changes that, and by doing that they achieve their goal, but it's really hard to spot. I went through the first one that didn't check if it was root, but it was actually setting the root. Another one is the X11 case, so the forgotten parenthesis. There are like two checks over here, the get UID and the get EUID, so the effective user ID. But with the second one, as you can see, they forgot the parenthesis. So this will make the statement always true, which means that it can use whatever module you want. And normally that was exclusively for the root, but now over here, because of the forgotten parenthesis, everybody can add a module. And it's just a mix-up of names. So if you have like a variable with the same name, you can do this stuff. Oh yeah, another one over here is assume you want to hide the following piece of code. So you want to hide that you want to remove everything in a particular in the root directory. So you want to rip out everything on a particular machine. But this statement is obvious to spot for a manual auditor. The way you can achieve that is you're going to encode it with base 64, for instance. You're going to encode it. You're going to decode it. on the fly and you're going to execute it. The good part over here is these 3 lines of code do not have to be on, in sequential order. You can spread them out over your application where it makes more sense to put that piece of code. So once you come to the execution of the string, you have no idea what's actually executed. It's not obvious. So you have to track back and try to figure out what's actually executed over here. So that's like a neat way to hide. Another way to hide from a manual inspector is using very simple substitution ciphers, like for instance ROT13, Foursquare, BFIT, and so on and so on. Over here, what they did is they wanted to insert something in a particular database, but they want to hide what kind of database they were inserting to, and they also wanted to hide what kind of values they were inserting to that database. So what they did up front was they declared a couple of variables, the database, the data, and data2. They didn't give any specific names, and they encoded it with ROT13. ROT13 is really useful because it only requires like 6 lines of code to implement. So if it's not by default in your application, you only need 6 lines of code and you have it over there. So what this was actually doing, it was inserting into the credentials database inside of a thread, but it was a little bit hidden from. So I've shown that example before where it was just like you insert it in the credentials database. Over here, it's much more harder to track down by use of for a manual auditor. So I've introduced like a little bit the classes of insider threats and a couple of examples. Jacob is going to tell what kind of techniques you can use to spot these malicious code.
Thanks, Matias. So I'm going to talk about a couple of techniques. First and foremost, maybe most popular, peer review, right? Manual code review. You're reading through code that somebody else in your organization wrote. Static analysis is, when it comes to security vulnerabilities, a great way to expand on and expedite the code review process. So we're going to talk about how static analysis can apply to finding insider threats. A couple of slides on runtime techniques for tracking these down, and then a little bit about how to interpret the results. It takes a little bit of a different mindset when you're looking for an insider as opposed to an accidentally introduced vulnerability. So first off, if you're doing a code review and you see those lines up at the top, you're going to ask, what on earth is that? Why is that in the code? That would look strange no matter what code base it was in. I mean, maybe it's a crypto key or something interesting, but whatever it is, there aren't many of them, right? The second line is a little suspicious, but there isn't anything completely out of the place there. You're checking a request parameter and then you're doing something based on the request parameter. That happens in a lot of code bases. Usually not with a hard-coded name and a very specific case like this, but that one might slip by. You know, if you came back after lunch and you were reading through code and you saw that one, you might let it go. What about the last one? You know, somebody over on this side of the room, I think, tracked down the problem with the last line of code there when we put one line of code on the screen and asked what's wrong with it. If that was one of 1,000 or 10,000 lines of code that you've read this day or week, you're much less likely to see it. So the ability to track these things down with manual code review is relatively low. And we've seen this with the success of insiders writing code like this that has lain dormant in code bases that have been reviewed year after year, because it's not a smoking gun. It's a breadcrumb that kind of points towards maybe a possible problem, something a little bit fishy, but again, it's nothing egregious in and of itself. So those are really the two challenges with using manual review for insider threats. One is your reviewer has to know what you're looking for, what he's looking for, what she's looking for. So they need to have a lot of domain expertise in terms of the kinds of techniques that insiders are going to use to do some sort of damage. So A, your reviewer has to be pretty well trained. They've got to be thinking about this problem specifically. Two, where do you look? Some vulnerabilities, it's easy. I'm going to look where important stuff is happening, right? The database queries that access the table with money in it, I'm going to go code review those, make sure there's no SQL injection. The pages that deal with authentication or other sensitive activity, I'm going to check to make sure XSS and CSRF aren't a problem. Insider threat code could be anywhere. And a lot of it isn't terribly interesting, right? A lot of it is, as Matias showed on the slide before, hiding the thing that you want to use, decoding the thing that you want to use, and then eventually maybe using it. And only the place where you use it would get any sort of security attention, because the other two can live in any arbitrary place, some dark corner of the code base. So, static analysis can help find insider threats in code two ways. One, it can represent all of that domain expertise. What are all the kinds of ways insiders might attack a code base in a set of rules? And granted, those rules aren't